Welcome to our 19th tutorial on Erlang. Today we're going to talk about Mnesia. Mnesia is a distributed telecommunication database management system. In today's tutorial, it's going to be a two-part series. We're going to focus this first part on our database logic, on the Mnesia logic. And in the next tutorial, we're going to implement the servers and supervisors. So with no further ado, we get started. If we open up our previous project, the Factorial project, what we want to do now is to add in another Erlang file which is going to contain the Mnesia logic, and we're going to call this database logic. The first thing we do when it comes to Mnesia is to first of all create a record. We're going to call our record Factorial, and it's going to have three fields. The first field will be node name. The second field will be comment, and third field will be created on. Now that we have the record, we need to find a way to initialize the database. So we create a function called initialize ini db, which takes in no argument, and we want to first create a schema. A schema is similar to rational database. Is a place we store a table, and we create the schema by calling Mnesia create schema. And we're going to create a schema for the current node, so we call a function, an Erlang built-in function called node. The second step is to start Mnesia. Finally, we need to create a try and catch block in order to check if our table exists. If the table doesn't exist, we're going to create a table. So we're going to call a try block, and in the try block we're going to call Mnesia table info. And table info takes in a type. This is going to be our table type, and our table type is going to be Factorial, since Factorial is a record. And we're going to also have a catch block. So if the table doesn't exist, the catch block will be thrown, and exit error is nothing. And now that the catch has been thrown, basically it means the table doesn't exist. So now we want to create a table, so we call Mnesia create table. We give it the name, we give the table a name, we call it Factorial as well, and we're going to give it a list of attributes. The attribute is basically going to be based on the Factorial record, so we're going to use Factorial as the attribute. So our table is going to have, our Factorial table is going to have a node name, comment, created on. We simply do this by creating a tuple attribute, and we call record info. And the record info is going to take a fields should I say, and the type, which is Factorial. The next step is to specify the type. We want to use a bag type, which basically means no primary key. So we specify a type and we call it a bag type. Now we need to specify where we're going to store our table, and we're going to first of all store our table on a disk, so we call disk copies, and a list of where the table is supposed to have disk copies, and we only want the table to have disk copies on the current node, so we simply call node, and we end our try block. Now we simply export this function, takes in no argument. The next function we need is a way to store values into the table, and for the purpose of this tutorial we want to store node name and comment into the database. So we write a function called storedb, and storedb takes in two arguments, which are node name and comment. For storedb to work, we need to create an Mnesia transactions. An Mnesia transaction is basically a logic inside an anonymous function. So basically the first step we need to take is to create an anonymous function that will write the Mnesia record into the table. So we start by creating our variable AF, which is the anonymous function, and remember the record takes in three arguments. So we need to create our first argument called created on, which is basically the calendar universal time that we created that specific file. So we use Erlang built-in function calendar, and we'll call universal time. Just send this. The next step is to write the record by calling Mnesia write. The hash function is basically to do with records, and we call our record factorial. We set the node name equals, we set the comment, we finally set the created on. So after writing the anonymous function, we're going to call Mnesia transaction, and we're going to send in the anonymous function AF. Finally, we're going to export the storedb, and it takes in two arguments. The next function we need to write is a way to get the comments in the data store using the node name. We do this by writing a function called getDB, and getDB takes in one argument called node name. Like the previous function, we also need to write an anonymous function AF, and let's just end it here. And after writing the anonymous function, we need to call Mnesia transaction, and send in AF. But since we're getting or a list in return, we want to send in the list into a variable called comments. which is going to be a list, and the comment is going to be returned to the parent color. Now let's get back into writing our anonymous function. We need to query the database for any record with the node name given into this function. So query. In order to query, we need to import an external library, UXLC, which is a query language. So before we go any further, let's import the UXLC library by calling include lib, and we delegate to the directory stdlib/include/qlc.hrl. Now that we have QLC imported, we simply call QLC, and we call the Q function, which is the query function. For the purpose of this tutorial, I am going to write out the query, then explain what it basically means. What this basically means is, using Mnesia table factorial, select those records whose node name matches the node name given to us. Once we've written our query, we need to get the results. So we create a variable called results. And now we have to execute our query by calling QLC E, and we send in the query just to execute our query. Basically, we're writing a query which, using the factorial table, finds out the record whose node name matches the node name, and we execute the query by calling QLC using the E function, and we send in the query, and the result is outputted into the result variable. Now the only thing we actually wanted in the results are the comments. To get the comments, we simply call in a list map, and we create a function. We're going to use a variable called item, which is an iteration of item factorial, and results. What this basically means is we want a list of just all the comments. So we give in the full list, which is the result, and we iterate through the list. Each iteration is an item, and we simply get the comment section of that single record, and it basically returns a list of comments inside results. And we execute this anonymous function by calling Mnesia transaction and putting the AF into the transaction, and it returns just the comments. And finally, we're just going to export this function, and it takes in one argument. Just to make things clearer, I'm going to write a second function which is going to get the comment and the created on value. So we're going to call our second comment getDB2, and it takes in one argument called node name to get our list. And like before, I'm just going to copy and paste this just to make things faster. The only part we need to change is the list map, since we already have the results based on the query above here. And now what we want is a list of tuples. So first thing is we put in a tuple here, and the first thing we want is the item factorial comment, and also item, and we get the record factorial, and we want created on. So it's basically simple as this, and we simply execute the query by calling Mnesia transactions. Now finally we export this function as well. It takes in one argument. The final function we need to write is a function that deletes all the comments using a node name as the identifier. So the function is going to be called deleteDB, and it takes in the node's name. Like the previous functions, to save time, I'm simply going to copy the anonymous function. We don't need the list this time, and the usual ending is to call Mnesia transaction and send in the AF, the anonymous function. And now we simply get the query and execute the query, put the result of the executed query into results, and now we're going to call in a second anonymous function for the delete. The second one is going to be called F. So just as the previous example on creating anonymous functions, and finally we call Mnesia transaction for this anonymous function F. Inside the second anonymous function, all we simply have to do is iterate through the result by calling lists for each. So for each record in the results, I want to call a second function, an item, or maybe I should just put results just to change this result. And we want to call Mnesia delete object, and we want to delete the object result, and results. So basically this is, I'm just going to change it so it looks a tiny bit nicer. So basically the second anonymous function F basically iterates through the results list, and for each result in results we delete the result, and we call Mnesia transaction to execute the F anonymous function, and after that we execute the AF anonymous function, the master anonymous function should I say, and we execute that in the final Mnesia transaction. And finally we export deleteDB. which takes in one argument. In the next tutorial, I'm basically going to create a database server, and we're going to add the database server into the supervisor. So until then, see you next time.